The term kinetic energy was coined by William Thomson, later known as Lord Kelvin, around 1849 to 1851. He replaced the earlier term actual energy with kinetic energy. The concept of energy associated with motion, however, had been explored earlier by others. Here's a more detailed look at the historical development. Early concepts, 17th–18th centuries. Gottfried Wilhelm Leibniz introduced the idea of vis viva living force, which is similar to kinetic energy, defining it as mv². Experimental evidence. Willem S. Gravesand provided experimental evidence supporting the relationship between mass, velocity, and the force of impact, later explained by Emily Duchatelet. Early use of energy. Thomas Young is credited with first using the word energy in its modern sense in 1807, though it didn't immediately gain widespread use, according to Universität Leipzig. Formalization of kinetic energy. Gaspard Gustav Coriolis and others formalized the mathematics of kinetic energy and the concept of work in the early 19th century. Adoption of kinetic energy. Thomson, Lord Kelvin, and William Rankine are credited with popularizing the term kinetic energy in the mid-19th century. Blowing away kinetic energy. Kinetic energy is the energy an object possesses due to its motion. It's the energy an object has because it's moving, and it's directly related to the object's mass and speed. The faster an object moves, or the greater its mass, the more kinetic energy it has, according to Study.com. Here's a more detailed explanation, definition. Kinetic energy is the energy an object has when it's in motion. It's the energy an object possesses that allows it to do work like moving another object. Formula. The formula for kinetic energy is K equals 1/2*. mv², where m is the mass of the object and v is its speed. Relativistic mass energy is based on a solid gravitational field behavior, meaning without gravity a propulsion force or velocity will not develop kinetic energy because there exists binding field energy that will make it kinetically plausible. Here is another Einsteinian illusogenetic debunking. Introduced by Rodney Kawecki, we will talk about the quantum physics theory framework of 2025. Kinetic energy maintained in relativity asserts a gravitational field illusogenetic flaw, meaning spacetime space field geometry goes not correlate as a standing hypothesis where the two comparable area metrics do not interact in a twin field geometric.
Your quantum physics rebuttal. In Albert Einstein's relativity theory on infinite predicts a moving object gains infinite mass when approaching the speed of light. This new insight's changing Einstein's predicament of infinite mass gain. Kawecki's statement, in the vacuum of deep space, where gravitational influence is near zero, relativistic mass increase is nullified. As a result, propulsion energy does not rise with velocity. Engines maintain a constant expenditure and can continually reimburse their own energy output. Let's break that down. Nullified mass in vacuum. Mass is only functionally inertial when space is curved by gravitational fields in low or zero gravity regions. Mass behaves as if weightless to the vacuum, therefore, no increase in resistance equals no inertial mass rise. No rise in propulsion energy. Since the ship is not accelerating against inertia, it isn't climbing an energy hill. Propulsion systems experience no relativistic fatigue. They can recycle, reimburse, or sustain their thrust output without exponential cost. Energy reimbursement mechanism. Engines may draw on space field pressure differentials x energy from quantum vacuum fluctuations, or exploit low resistance tunneling corridors space field contraction zones. Principal statement. Quantum physics mass energy nullification principle. In gravitationally silent vacuum, the relativistic rise of mass and energy is nullified. A spacecraft traveling at superluminal speeds within a compressed space field envelope experiences no inertial drag or exponential energy requirements. Propulsion energy remains constant, enabling continuous operation and self-reimbursement. Engineering implication. This opens the door to a new propulsion model, based not on overcoming mass but on riding null-resistance corridors, using constant energy engines that may draw from CPE zero-point energy field skill tunneling, geometries or photon compression mechanics if applicable.